Hello, grade 10s. Today we will continue our study of linear functions. We will join Eloise and Segra as they discover how a change in the value of q of the linear function will affect the graph of the function. We already know that the a value changes the gradient or slope of the linear function. Eloise is going to keep the gradient of the parent function the same while she investigates the changes the q value will make. Let's join Eloise and Segra now.
We are going to keep the gradient the same for all the graphs we look at. That means that in the formula, we will keep the value of a the same. This way we can focus on the changes to the value of q. The gradient of the parent graph is a equal to 1, so let's keep a gradient of 1 for all our graphs. Now I'm going to move the parent graph. Let's see what happens when we do this. If I shift the graph up 1 unit like this, what do you think the formula of this new graph will be?
Well, it's still a straight line, so the formula must be y equals a times x plus q. So we need to find the gradient and the y-intercept.
Okay, and what do you think they are going to be?
The y-intercept is easy. It's 1.
Right. Q is 1, so we just need to find the gradient.
The gradient doesn't change, so it stays 1, which means that the formula of the line after the shift is y equals 1x plus 1.
Well done. So when the parent graph is shifted 1 place up, the new graph has a formula of y equals x plus 1. Now let's go back to the graph of y equals x. How do you think the formula will change if we now shift the graph 2 positions down, like this?
This shouldn't be too difficult. The y-intercept is -2, so q is -2, and the gradient is again 1. We kept the slope of the line the same and just moved it down.
That's right. So we get the formula y equals 1x minus 2. Now I want you to have a look at all the graphs that we have done so far. The parent graph y equals x, the one that shifted up, and this one that shifted down. Do you notice anything interesting about them?
Well, the 3 graphs kind of look like they could be parallel to me.
And why do you think that is?
Is it because they all have the same gradient?
Yes, the gradients are the same, but how can you be sure they are parallel? What makes lines parallel?
I think I've got it here in my toolbox somewhere. Let me check. Where is it? Here. Parallel lines are lines that are the same distance from each other. Perhaps you can check that on these lines. It shouldn't be too hard because we can use the blocks of the grid to help us.
Okay, explain to me how you would do it.
If I count the blocks along the y-axis, the distance between the parent graph and the x plus 1 graph is 1 block. And the distance between the parent graph and the x minus 2 graph is 2 blocks.
Yes, but remember, if we want to prove that the lines are parallel, we must make sure the graphs are the same distances apart anywhere we look. Here, where x equals 0, it is easy to see the distances between the parent graph and the shifted graphs.
Sure, but it's still the same where x is 3. Look, the distances between the lines are still the same. 1 between these 2 and 2 between these 2.
You are quite right. It will be the same at any point we try. At any x along here, the distances between the lines stay the same. An important thing to remember is that the gradient of a straight line doesn't change. So the lines won't change direction, and the distances between them will also not change.
I think I understood what we did, but can we go over it again? Just in case, I could have missed something.
Sure. First we started with a parent formula. The one we used was y equals x, where the gradient was 1. So the value of a in the formula remained unchanged at 1. The only other thing in the formula that could change was the q value. Then we compared two different graphs to the parent graph. In this graph, the Q value was 1, and in this graph, the Q value is -2. Let's look at this in a different way. If I give you the formula for a linear graph, can you work out how the parent graph would shift to make the new graph?
I'll give it a go.
Okay, here is the formula. Y equals x minus 4. How does the parent graph shift to make this graph?
Give me a moment to draw the graphs. There we are. The gradient is the same as for y equals x, but now the graph cuts the y-axis at -4. So we shift the graph down 4 places and we keep it parallel to the parent function.
Well done. So -4 shifts the graph down 4 places. In your new graph, it's as if each point on the parent graph has dropped by 4 units. So to recap what we have seen here, if the graph of y equals x shifts up or down q places, each y value on the parent graph will be shifted up or down q places on the new graph.
Thank you for joining us, grade 10s. Remember to try the task video at the end of this section. You'll also be able to learn more about linear functions on our website, www.mindset.co.za/learn.